Hello, today we are going to do the second part of 1.5, solving compound inequalities. Alright, this means, compound inequalities have to do with and and or, okay, and the best way I can describe an and or is this part in red, okay. When I tell my husband that I want to go to dinner and a movie, what am I expecting? I'm expecting to go to both things, dinner and a movie. If I tell him dinner or a movie, then I'm saying one or the other. You know, it could be both, it could be one, it doesn't matter, I'm flexible there, okay? So that's how I want you to think of the differences there, okay? So an and statement, so that's a conjunction statement, okay? So meaning both sentences are true, okay? So both sentences are true. So when we go to graph, we now have two important numbers, 2 and -3. So you want to make sure you put both numbers on your number line and make sure that you put the smaller one to the left. So -3 to the left and +2 to the right. Now, and is only when they're both true. So I don't shade until I figure out what covers both things. What I mean by that is x is less than 2, so that's everything to the left of 2. So I'm going to do a little arrow there. And I know x is greater than -3, so everything's bigger than -3. So if I were to shade these, this one would go all the way to the left, to the right. And let's see, I'll do this one in green. And then the less than 2 would go all the way to the left, okay? The only numbers that satisfy both statements, okay, is the numbers in between -3 and 2. So I shade there. That's where that green and red overlapped, okay? Both sentences are true. So we have 0. 0 is smaller than 2 and it's bigger than -3, okay? But I can't do -4 because it is not bigger than -3, okay? Alright, so sometimes for B, they're written this way. Okay, this is the only time it's written. These arrows always go to the left, like this, when you have one variable. You will never see it as 3 greater than x is greater than 0. Do not do that. Okay, so here, we can separate it and say 3 is less than x, and x is less than 5. And then all we have to do is just transform how this, or flip how this is written and say x is greater than 3 and x is less than 5. And that's an x up there. Alright, so now we have two important numbers, 3 and 5. And we want everything bigger than 3 and less than 5. So to the right of 3 and to the left of 5. And the only spot they overlap is right there. Okay? Now for the compound inequalities. Okay? For the disjunction, the or inequalities. Same thing. So we have 5 and 8. So we started the same way, but now, alright, it's an or. So one of them's true or both of them are true. It doesn't matter. So I highlight or I shade whatever it tells you. Everything less than 5. Do it. Everything greater than 8, do it. You just do exactly what it says. Okay? So for D, you have 3 and -1. Shade everything bigger than 3, done. Shade everything less than or equal to -1. That equal to means you shade the circle. Perfect, done. Alright? Let's keep going. Alright, so now we're going to have special cases. Those are your typical and or statements. Okay, and is shaded in the middle, ors are shaded on the outside. However, that doesn't always happen. Okay, and I need you guys to realize that. Okay, that different things happen. So you need to understand why and the how, and then that'll make your answers a whole lot easier. Okay, so let's do number 1. So we have 2 and -5. So -5 on the left, 2 on the right. It's an and statement. So we're shading what they have in common. So everything greater than 2, so that's to the right of 2, and everything less than -5, so to the left of -5. Notice there is nothing shaded. I'm sorry, there's no overlap. So where is there the same? Nowhere is it the same. So we shade nothing. This is a no solution. All right, so the answer here is no solution. You can either write it out as no solution, or you can write with a circle and a slash through it. Okay, that is not a 0, that is no solution. If you're trying to put your answer as 0 and you put a line through it, that's wrong. Okay, that is no solution. Okay, so you leave a completely blank graph. Okay, so the graph is blank. All right, number 2. Okay, we have 2 and -5 again. So -5 on the right, 2 on the, -5 on the left, 2 on the right. So we have x is less than 2, x is greater than -5. It's an or statement. You do what it says. Everything smaller than 2. All right. Everything greater than -5. Notice we just shaded everything. This is all real numbers. Every number satisfies this equation. This inequality. You can write that with an R and a line through it. Okay? Just so you guys. Trying to make sure that looks separate. Okay. So, completely shaded everything, and it's all reals. All right? That was an or statement. So notice an or statement ended up being everything. Okay, so you wouldn't write this as an answer. You would write this as an answer. All reals with an all shaded graph. An empty graph with no solution as your answer. Okay? All right, what about number 3? Let's see what happens there. Okay, we have -5 and 2. Or statement. You just shade what it says. Everything less than 2. Everything less than -5. Well, is that even a compound inequality anymore? No. Did I even need this part? Was this part helpful at all? No. It was extra information. And sometimes that'll happen when you solve these inequalities. So really, our answer can drop that. And it just becomes x is less than 2. Okay? Number 4. -5, 2. So we're going to do an and statement, so we need to shade what they have in common. So less than 2 is to the left of 2, and less than -5, so left of -5. Well, notice what we end up shading. The only part where they overlap is to the left of -5. So was this less than 2 even needed? No, it's extra info. Our answer is just x is less than -5 with the left part shaded. Okay, so this is how I expect your answers. All right. Now let's actually solve some compound inequalities. Okay, so let's start with the odd one, the and inequality. I know it's and because it's written like a sandwich. Okay, so we have 8 is less than or equal to m plus 6, and m plus 6 is less than or equal to 14. Okay, we're chopping it into pieces. We've got this inequality and that inequality. Okay, think of it like we're twisting off the, I don't know, an Oreo. I don't know. Can you tell I'm hungry? All right, so let's solve it. So we move the 6 over. So we get 2 is less than or equal to m, and m is less than or equal to 8. Okay, I'm going to rewrite this m, this first one. So m is greater than or equal to 2, and m is less than or equal to 8. So we go in and graph that, and we get 2, 8. And statement, we're shading the overlap. So we want everything bigger than 2 and everything less than or equal to 8. The overlap of those two is going to be everything in between. So this is exactly how I would expect you to write your two answers. You have your graph answer up here and your inequality answer. All right, let's do another one. Okay, feel free to pause the video and try this on your own and see if you get the same thing as me. All right, we get x is less than or equal to 5, or x is greater than or equal to negative 5. So we have 5 and negative 5. Or statement says we shade whatever it says. So less than or equal to 5. And then greater than or equal to negative 5. So our answer ends up being all real numbers, and we end up shading everything. Number 7, we get x is less than negative 2, or x is greater than 1. Alright, we put negative 2, 1. Or statement, shade what it says. Less than negative 2, greater than 1. So we leave our answer as that. And there's our graphed answer. All right, hopefully you're knocking these out of the park. Okay, let's make it a little bit more complicated, shall we? All right, I'm going to go ahead and start solving this one. So we get 5x is greater than negative 25. Then we get x is greater than negative 5. And let's go ahead and work out the right side now. 4 minus 8x plus 9 less than 29. Negative 8x plus 13 is less than 29. Negative 8x is less than, what is that, 16? X is greater than negative 2. So we have, well, I won't write my answer quite yet. Let's see if it's the same as it is in the graph. So we have negative 5 and negative 2. And wants the overlap, so we want everything bigger than negative 5 and everything bigger than negative 2. Well, the only way these arrows are going to overlap is over here to the right of negative 2. So our answer is just x is greater than negative 2. Perfect. Done. Keep doing it. Number 9. We get x is greater than negative 2 and x is less than 3. We graph those, negative 2, 3. And graph the overlap. Bigger than negative 2, less than 3. This one's nice and simple, your typical one. We don't have to change anything. Perfect. Number 10. We've got x is greater than 6 and x is less than negative 8. Put negative 8, put 6, and we want the overlap, so bigger than 6, smaller than negative 8. No way those are going to overlap. This is your no solution. Nothing shaded. All right. Let's see, 11. All right, word problem. Okay, so now let's apply it to the real world. Billy's test grades are 64, 75, 81, and 94. What's the lowest test score Billy can get on the last test and have at least an 80 average? Okay, so we want his average to be at least an 80. Okay, so think about what that means. Oh man, you say this all the time. Come on, Miss Cross, I need to at least pass. Okay, so I need it to be bigger than or greater to 80. Okay, so how do we get the average? Well, we add up all of Billy's test scores and divide by how many there are. But wait, isn't the whole idea is figure out what he can get on the last test? We'll call that x. So really we have to add another test score and divide by 5. Hopefully you guys saw that. If not, hopefully now it's ingrained in your brain. Okay? So we add them all up and divide by 5, and that's going to be greater than or equal to 80. And so now all we have to do is solve for that variable. Alright, so we get out our handy dandy calculators. 64 plus 75 plus 81 plus 94 is 314 plus x. But we can get rid of that dividing by 5 by multiplying it by the other side. So we get 160. That doesn't seem right. Nope, I did it wrong in my head there. Just kidding. 400. Woo. It's a silly math trick I did in my head wrong. Just wasn't thinking right. Alright, so now we subtract the 314. We get x is greater than or equal to, we subtract, and we get, what, 86? So, that x has to be bigger than or equal to 86. So what's the lowest he can get on that score? An 86. Okay? Hopefully that makes sense. Hopefully the assignment is doable at this point. If it's not, get a hold of me at those Zoom calls, alright? See you guys later.